Morning everyone, I am Jessica Mingawan, and for today's video, I will tackle about one of the brilliant and productive French mathematician in 17th century. I will explain about the Père de Fermat and his contribution to mathematics during the 17th century.
Good morning everyone, I am Marial Arbataluna from Bachelor of Science in Mathematics. Today's video, I will tackle about René Descartes and his contribution to mathematics during 17th century. So prepare your mind and enjoy watching.
Oh my god, what is this theorem? I don't understand at all. My head hurts just looking at it. Let me call Jesse. His phone is ringing but he didn't answer at all. Okay, I understand. But what should I do? It's so hard. It's beyond my level, oh my god. Anyways, I'm so tired. I'll just have to take a nap. But Lord, please, please help me. If only there was someone who could help me. Someone out there who could explain everything to us. But anyway, I just have to take a nap. My head hurts so much. Where am I? What is this shabby place? Am I dead? Oh no!
You are not dead, young girl.
Who is it? Is it a ghost? So scared!
Hey, young girl, I am not a ghost. I'm Crooks.
Who is it? Who are you? And why did you dress up like that? What's going on here?
I am Crooks, the legendary historica. I know why you're here. Young girl, I expected you and your friend. Let me guess. You're here because you need someone to explain people about the history, right?
What? Wait. Jesse? Jesse's here too? Where is he? What's going on here?
Yes, he's with Kusha, and probably they were talking about the things that Jesse wanted to know. How about you, younger? What are your questions? Anything about history? I'll explain it to you.
Really? Thank goodness. But, Mr. Crooks, I want to know about a French mathematician. His name is, Fermat. And also about his contribution about mathematics during 17th century. Can you help me, please?
You want to know about Père de Fermat, right? Père de Fermat is one of the most brilliant and productive mathematician in his time. He was born on August 17, 1601. He often called as a father of modern theory of numbers. He contributes on the differential and integral calculus, number theory, optics, and analytic geometry, as well as initiating the development of probability and correspondence of Pascal.
How about his study? I thought he has a theorem called... What's the name? I forget the name, but all I know is that he has a theorem about prime numbers.
The first contribution is the analysis on curves. Fermat's study of curves and equations prompted him to generalize the equation for the ordinary parabola ay equals x squared, and that for the rectangular hyperbola xy equals a squared to the form and negative 1y equals xn. The curves determined by this equation as known as the parabolas or hyperbolas of Fermat according as n is positive or negative. He similarly generalized the Archimedean spiral r equals a theta. This curve in turn directed him in the middle 1630s to an algorithm or rule of mathematical procedure that was equivalent to differentiation. This procedure enabled him to find equation of tangents to curve and to locate maximum, minimum, and inflection points of polynomial curves, which are graphs of linear combination of powers of the independent variable. During the same years, he found formulas for areas bounded by these curves through a summation process that is equivalent to the formula now used for the same purpose in the integral calculus. Second contribution is the disagreement with Cartesian view. As with La Geometrie, which was an appendix to Descartes' renewed Discours de la Méthode, Fermat disagreed with Cartesian views regarding the law of refraction, the science of the angles of incidence, and refraction of light traveling through mediums of varying densities are in a constant ratio. Descartes has argued that the density of the two media involved in the refraction causes light to move more quickly in an effort to support the sign law. Fermat remarked that he appeared to be at odds with the Aristotelians' belief that nature always takes the shortest route 20 years later. Fermat demonstrated that the law of refraction is consistent with his principle of less time by using his method of maxima and minima and the consumption that light travel more slowly in the denser medium. His argument regarding the speed of light was later found to be in agreement with the wave theory of the 17th century. That scientist Christian Huygens, and it was experimentally verified by A. H. L. in 1849 physics. One is the number theory. Fermat made fruitless attempts to convince Pascal to work with him on his number theory study. Fermat had discovered new discoveries in the so-called higher arithmetic, many of which related features of prime numbers, and was motivated by an edition of the arithmetic of Diophantus, the Greek mathematician of the 3rd century AD, published in 1621. Those positive integers that have no factors other than 1 and 4n plus 1 can only be expressed as the sum of two squares is one of the most beautiful of these. Fermat numbers, and when a number of this form is prime, we call it a Fermat prime. The only known Fermat primes are the first 5 Fermat numbers. F0 equals 3, F1 equals 5, F2 equals 17, F3 equals 257, and F4 equals 65,537. A simple heuristic shows that it's likely that these are the only Fermat primes. As the important results is the Fermat subtheorem and Fermat's theory, also known as Fermat's primitive test, are the first number theoretic statements made by French mathematician Pierre de Fermat in 1640. All prime numbers p and all integers. For A, P is divided into A. Pairs are relatively prime and P is exactly divided into A. A number n that is not exactly divisible by A must be a composite number of some A, and vice versa is not always true. For example, if A equals 2 and N equals 341, then A and N are relatively prime. And 341 can be divided into exactly 2, 341 minus 2. However, since 341 equals 11 times 31, it is a composite number, a special type of composite number called pseudo-prime. Therefore, Fermat's theory provides a test that is necessary but not sufficient for prime numbers. Fermat's last theorem, also called Fermat's great theorem, the statement that there are natural 1, 2, 3, and now and so forth, 1x, y, and z, that is that x n plus yn equals zn, in which n is the natural number greater than z. For example, if n equals 3, Fermat's last theorem states that no natural number x, y, and z exists that x cube plus y cube equals z cube. The sum of two cubes is not a cube. It is impossible for a cube to be a sum of two cubes, a fourth power to be a sum of two fourth powers, or in a general, for any number that is a power greater that is a power greater than the second to the sum of two like powers. I have discovered a truly remarkable proof of this theorem, but this margin is too small to contain it. This is what he said in his last theorem. For centuries, mathematicians were baffled by this statement, for no one could prove or disprove Fermat's last theorem. Now, young girl, do you understand it now?
A little bit, but thank you so much, Mr. Crooks. And I have to find Jessie. We have to go home. Thank you for your time, Mr. Crooks. La 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 la. That's Crooks and Crucia. So that means Jessie was there too. Wow. Where is Jessie? Good day, young man. I've been waiting for you.
So, you were expecting me to come here? What this place?
Be grateful to your friend. You are inside of her mind. Me and Crooks is just her illusions because she wants someone to help you and her about your lessons.
You can help us?
I can? I am Crucia the Great after all. So, young man, what is your doubts and confusions?
About René Descartes and his contribution to mathematics.
You're in a lucky place, young man. I know about René Descartes after all. René Descartes, also known as Renatus Cartesius in Latin, was born on March 13, 1596. He is a French philosopher, mathematician, and a scientist. He is one of the key figures in the scientific revolution and also a father of modern philosophy and of the analytic geometry. One of the most enduring legacies of Descartes was the development of Cartesian or analytic geometry, which uses algebra to describe geometry. He invented analytic geometry, linking the previously separate field of geometry and algebra. And because of his development of analytic geometry and Cartesian coordinates in the mid-17th century, the orbits of the planet are soon allowed to be plotted on a graph. Also, he is credited to be the first mathematician who used superscript for powers or exponent. He has lots of contribution to mathematics during 17th century. As I said earlier, he developed the analytic geometry, also known in classical mathematics as coordinate geometry or Cartesian geometry. It is the study of geometry using coordinate system. This is the contrast to synthetic geometry. Analytic geometry is a mathematical subject that uses algebraic symbolism and methods to represent the solved geometric problems. The importance of analytic geometry is to establish a correspondence between geometric curves and algebraic equations. This correspondence allowed the geometric problem to be reformulated as an algebraic equivalent problem and vice versa. You can then use the method of the one subject to solve the problem of another subject. For example, computers manipulate algebraic equations to create animations for display in games and movies. The Cartesian coordinate system, on the other hand, is a field of mathematics that describes how points can be uniquely represented in an n-dimensional coordinates plane. It uses horizontal axis, which is the x-axis, and the vertical axis, which is the y-axis. The next contribution is in 1637. René Descartes invented a rule in which the known of an equation are represented by XYZ and known by ABC, contrary by Vet-Costume. Descartes is still widely used. René Descartes also gave a standard superscript to represent powers or exponent. That is, he first showed the square of the variable x as x squared. His analytic geometry was the basic of Newton's calculus, and he developed an early concept of the law of conservation of momentum. He paved the way for other mathematicians to create the standard analytical notations used today for both algebra and logic. The next one is he professed that the abstract quantity a squared could represent land as well as an area. He opposed the teaching of the mathematician such as Francois, who insisted that the second power must represent an area. Even though he didn't pursue the topic, he was the first to imagine a more general science of algebra, or also known as the universal mathematics. Descartes' work provided the basis for the calculus developed by Newton and Leibniz, who applied the infinitesimal calculus to tangent line problem, thus permitting the evolution of that branch of modern mathematics.
His rule of signs is also a commonly used method to determine the number of positive and negative roots of a polynomial. For example, the polynomial of x to the power of 5 plus x to the power of 4 minus 2x to the power of 3 plus x to the power of 2 minus 1 is equal to 0. Changes signs 3 times, so it has at most 3 positive real solutions. Substituting negative x for x gives the maximum number of negative solutions. Descartes had influenced the young Isaac Newton. Newton continued Descartes' work on cubic equations, which freed the subject from fetters of the Greek perspectives. The most important concept was his very modern treatment of single variables. In cubic equation, Descartes explored Witt's approach in detail in his law geometry. He extended Witt's approach by showing that trisecting the arc, both internally and externally, generates both of the positive roots of the reduced equation. The formula is z to the power of 3 is equal to p times z plus q is equal to 0. The last one is his contribution on the field of optics. He showed using geometry construction and the law of refraction, also known as Snell-Descartes law. It is a formula used to describe the relationship between the angles of incidence and refraction. When referring to light or other waves passing through a boundary between the two different isotropic media such as water, glass, or air. That's all that I can give you, young man. The rest is up to you. Now, let me recite what Descartes said. I took pleasure above all in mathematics because of the certainty and the absoluteness of its reasons. But I had not yet discovered its true use. I was astonished that way such solid foundation, nothing more eminent, had ever been built upon them. Good luck on your journey, young man. Oh my god, that was just a dream. But anyway, I did wish that someone who could help us. May wish come true. Now I can answer this problem. Thank you, Lord.